Hi, today I'd like to show you how to tackle this here physics problem without any calculations on energy. So it says a bullet is fired straight upwards with a velocity of 300 meters per second. What's its maximum height? Ignore all friction. Well, the only force acting on the bullet on its way upward, if we ignore all friction, would be the gravitational pull. So this will slow the bullet down all the way until its velocity is zero, all the way up. So if it starts at 300 and ends at 0 meters per second, we can state, at least, my pointer right there, that the change in velocity, or delta v, equals 300 meters per second. Also, that if it starts at 300 and ends at 150, that would mean that the average velocity, or v avg, equals 150 meters per second. Well, first we're going to use the formula A equals delta V over delta T. Because we know an acceleration, it is the acceleration due to the gravitational force, which is 9.81 meters per second square, equals delta V, 300, over delta T. Okay, so that means that we can calculate delta T by, using our calculator, of course, typing in 300 divided by 9.81, 300 divided by 9.81 equals 30 point, pointer there, 30.58 seconds. Okay, so now we know the time it takes for the bullet to go all the way upwards. Now the final formula I would recommend to use would be the distance equals the average velocity times the time. Okay, the distance, of course, being vertical in this instance, so distance equals the average velocity of 150 times the time we just calculated, 30.58 seconds. Okay, if we multiply the number that we still kept on our screen of our calculator, if we multiply that number by 150, then our final answer would be the distance equals 4587 point some other digits meters, but as our initial only number that was given only has 3 significant digits, our final answer should be the distance equals 4.59 kilometers, which is, surprisingly, the exact same number we would get if we calculate this thing just using energies. Thank you for watching.